Hey everyone, welcome to today's session on building a super cool feature for your mobile apps using React Native. Imagine you're creating an app where users need to upload their photos, maybe a profile picture or a snapshot of something interesting they've encountered. How do you make this process seamless and interactive? That's exactly what we're diving into today. Our focus will be on creating a React Native component that empowers users to either snap a new picture using their camera or select an existing one from their device's gallery. But we're not stopping there. We'll also learn how to convert these images into a base 64 string. Why? Because a base 64 string is a clever way to encode images that can easily be sent over to a server as part of a request, without needing to deal with the complexities of file uploads. This method is super handy for quick image previews, storing images directly in databases, or simply when you prefer to send data in a string format. This component is immensely useful because it not only enhances the user experience by offering flexibility in how they provide input, but also tackles the technical challenge of image handling and data transmission in modern app development. So why is this exciting for you as budding developers? You'll get hands-on with integrating camera functionality, managing permissions, processing images, and interacting with servers, all essential skills in the app development world. Plus, mastering how to handle images and convert them to a base 64 format is a valuable addition to your toolkit, applicable in various scenarios beyond just mobile apps. Now let's dive into the code and see how all these pieces come together to create a seamless image handling experience in React Native. Let's break down the React Native component to guide you through understanding how each part of the code contributes to the overall functionality of allowing users to capture or select an image, convert it to a base 64 string, and send it to a server. At the very beginning of our component file, we import necessary modules from React and React Native libraries, as well as the launch camera and launch image library methods from React Native Image Picker. This step is crucial because it sets up our component with the tools it needs to interact with the device's UI elements, like buttons and views, and access the device's camera and photo library. React and useState. We import React to use its core features and the useState hook to manage state within our component. The state is used here to store the base 64 string of the selected or captured image. React Native components. We import button, view, and alert from React Native. These are basic UI components. View is used to lay out our buttons, button to trigger actions, open camera or image gallery, and alert to display any error messages. Image picker methods. The launch camera and launch image library methods are imported from React Native Image Picker, which are essential for accessing the device's camera and gallery. Step 2, the component function. We define a functional component named Image Picker Component. This function is the core where we implement our logic for opening the camera, selecting an image from the gallery, converting the selected image to a base 64 string, and handling the upload process. Inside the component, we initialize a piece of state using useState to keep track of the image's base 64 string. This state acts as a local storage to temporarily hold the image data until we're ready to send it off to the server. We then define an asynchronous function openCamera that uses launch camera to open the device's camera. This function is wrapped in a try-catch block to handle any exceptions that might occur while accessing the camera, such as permission issues or hardware malfunctions. The function specifies options for the camera, like saving photos to the gallery and including the base 64 data in the response, checks for user cancellation or errors, and updates the component state with the base 64 string if successful. Similarly, the select image function is defined to handle image selection from the device's gallery. It also specifies options for the image picker, manages user actions, cancel or error, and updates the state with the image's base 64 string. This function mirrors the structure and error handling of openCamera, but uses launch image library instead. Send to server is a mock function where you typically integrate API calls to upload the base 64 string to your backend. Although it's a placeholder in this example, it represents an important step in processing the image data for real-world applications. Finally, the component returns a React Native view containing 2 button components. Each button is tied to one of our functions, openCamera and selectImage. This setup provides a simple user interface for interacting with the component's functionality. The last line of the code exports Image Picker component, so it can be used in other parts of your application. This step-by-step walkthrough demonstrates how to build a feature-rich React Native component for image handling. Each step is designed to contribute to the overall functionality, from setting up the UI to integrating with device capabilities and preparing the data for server communication. By understanding these components, you're well on your way to implementing sophisticated features in your mobile applications. As we wrap up today's session on integrating image handling capabilities into your React Native applications, it's important to reflect on how the component we've developed fits into the bigger picture of web and mobile development. The beauty of what we've created lies not just in its immediate functionality, but in its simplicity and reusability, core principles that drive efficient and effective software development. In the world of web and JavaScript technologies, writing modular and reusable code is akin to building with Lego blocks. You create small, independent pieces that can be combined in numerous ways to build complex structures. Our image picker component is a perfect example of this approach. It encapsulates all the logic needed for users to capture or select images, process these images into a format that's easy to transmit over the web, base 64 strings, and then prepares them for upload to a server. This self-contained functionality makes it incredibly simple to integrate this component into larger applications, whether you're building a social media platform, a content management system, or any app that requires user-generated image content. Moreover, the principles we applied in developing this component, such as state management with React's useState, asynchronous JavaScript for handling operations like image picking and camera access, and error handling, are applicable across a wide range of development tasks in the JavaScript ecosystem. These are skills and techniques that you'll find invaluable as you progress in your development career, offering a foundation upon which you can build more complex functionalities and applications. Integrating our component into a larger application would typically involve placing it within a form or a page where users need to upload images. Thanks to its reusability, you could easily customize or extend the component to suit different parts of your application, such as profile picture selection, content creation forms, or any feature that requires image inputs from users. Thanks for watching, everyone, and don't worry if you missed anything. We've added a link to the source code in the description. If you found this video to be helpful, please like and subscribe for more of the same. Thanks again. And remember, we're always learning, so keep coding, keep exploring, and keep building amazing web applications.